have a look at this, we want to simplify on the left-hand side. And the first one, we are squaring a binomial. We did look at the shortcut for that last time. So if you have a binomial and you're squaring it, you could square the first. You're going to have the sign that's here, and you're going to double the first times last. And then you're going to square the last. And negative times negative will give you positive b squared. That's opposed to writing it out twice and doing the FOIL. It just saves you some time when you have to do this a lot. All right, so we are squaring a binomial here. And so 7 cosine theta, we want to square that first. So that is going to be 49 cosine squared theta. All right, we're going to do minus 2 times multiplying the first and last. So 7 times 2 is 14. 14 times 2 is 28. And we'll have cosine theta, sine theta. Right, then we're going to do, we'll have plus, and we're going to square the last. 2 squared will be 4, and we'll have sine squared theta. That is the first one. The next one they gave to us in the example problem, but we can work it out here. All right, it is also squaring a binomial. So we're going to do the first squared. So 2 squared will be 4 plus cosine squared, not a plus in between, but 4 cosine squared theta. We're going to do double the first times the last. So 2 times 7 is 14. We'll use the sign that's here. 14 times 2 is 28. So plus 28 cosine theta sine theta. And we're going to square the last. So this is going to be plus, sorry, I ran out of room there. 7 squared will be 49 sine squared theta. Great, and then we're going to look and see what we can clean up here, if anything. Right, this term is going to cancel. This minus 28 cosine theta sine theta and 28 cosine theta sine theta, that's going to cancel. This was a theta, not a 0. All right, and let's look here and see if we group these together, because we're allowed to do that. So if we have 49 cosine squared theta plus 49 sine squared theta, we could factor a GCF out of those. So we could factor out a 49 cosine squared theta plus sine squared theta. And remember your Pythagorean identity, sine squared plus cosine squared equals 1. So that we're going to be able to use that here. So this is going to be 1 by the Pythagorean identity times 49 is going to give us 49. All right, let's see what else we have. We've used up these two terms. We still have these two, and it's going to work the same way. We have 4 sine squared theta plus 4 cosine squared theta, and we can group those and factor out a 4. So 4 sine squared theta plus cosine squared theta. Again, we can use the Pythagorean identity. This is going to equal 1. So we have 4 times 1. and that gives us 4, which will give us a 53 on the left-hand side equals 53. So we have established this identity, and they ask in the questions, this came from my math lab, they ask in the questions, the last one, which of the identities helped us to do this, and it was the Pythagorean identity, and we used it twice.